Okay, so we have looked at how we count oxidation state, and then now we are going to look at oxidizing agents and reducing agent. So substances that undergo oxidation is the reducing agent. Okay, so using this example, let's take a look. Okay, in this equation, I have 2 HBr, my hydrogen bromide, plus chlorine, give you hydrogen chloride plus Br2. Okay, so we can explain it this way. Hydrogen bromide loses hydrogen to form bromine. So HBr is oxidized, right? Because oxidation definition is gain oxygen, lose hydrogen. So since you say that HBr is lose hydrogen, it is oxidized. The HBr is oxidized. Okay, and HBr cause your chlorine to gain hydrogen. Okay, so HBr cause your chlorine to gain hydrogen. It causes chlorine to be reduced to hydrogen chloride. So since it caused chlorine to be reduced to HCl, hydrogen chloride, then HBr is the reducing agent. So HBr was oxidized and it is the reducing agent. Okay, in a reduction example, chlorine gains hydrogen to form hydrogen chloride. So gain, lose, right? So it's lose, gain. Lose oxygen, gain hydrogen is the reduction process, right? So chlorine gains hydrogen, chlorine is reduced. So chlorine causes HBr to lose the hydrogen. So chlorine is the oxidizing agent, right? So over here, chlorine is reduced, but it causes HBr to lose. So it causes HBr to lose, it causes HBr to be oxidized. So chlorine is the oxidizing agent. And there we have it. Reduction will be oxidizing agent. Okay, we will look at the common oxidizing agent as well as reducing agent. So remember, oxidizing agents undergo reduction. So most common oxidizing agent you are going to use in the lab are KMnO4. It must be acidified. So acidified potassium manganate 7. Okay, it will turn colorless. So KMnO4 potassium manganate itself is purple and it will turn colorless when it is being reduced. When it is acting as an oxidizing agent, it will turn purple to colorless. Okay, hydrogen peroxide H2O2 is both a reducing agent and oxidizing agent. It can be oxidized and reduced at the same time. Okay, so hydrogen peroxide, this one, it remains colorless, but when it is acting as an oxidizing agent, it will cause your reducing agent to change color. Okay, chlorine commonly undergoes this reaction to form Cl minus. So it will add electrons here. Okay, so gaining electrons, this part is reduction. Right, so chlorine, it undergoes reduction. It is the oxidizing agent. Okay, and what will happen when it is being reduced from chlorine to chloride? The yellow-green gas will turn colorless. So chlorine itself is yellow-green gas and it will turn colorless. Likewise, my iodine will have this equation, I2 plus 2 electrons to give you I minus, 2I minus. Okay, so in this reaction, same thing, it gains the electrons, right? So this is being reduced. When it is being reduced, it is the OA. Okay, so the black or brown solid will turn colorless. My iodine or yellow-brown solution or yellow, will turn colorless. Okay, iron 3 itself is an oxidizing agent. It can be reduced to iron 2. So your common equation will be Fe 3 plus plus electrons to give you Fe2 plus. Okay, so when it gains electrons, again reduction is gain, it is oxidized. So iron 3 under QA, you will learn that it's red, brown or yellow in color. Okay, so the yellow iron 3 will turn light green. Under QA, Fe2 plus is green in color. Okay, so these are all common oxidizing agents. The first two are the very common ones that you use a lot in the lab. Okay, the next one is your reducing agent. So I have Ki. Really, I'm looking at the I minus. The I minus will form back I2. Okay, how does it form I2? Plus gaining electrons on this side. Okay, so what's going to happen is this part is gaining, this part is losing. So oxidation is lose, right? So it is undergoing oxidation. It is the reducing agent. Okay, so Ki itself is colorless. It will form your brown, yellow brown, blue, red brown iodine solution. Okay, over here. H2O2, like I tell you, is the OA and the RA. When it is acting as the reducing agent, it will cause your oxidizing agent to change color. Okay, and when it is undergoing a reduction reaction, this is the equation that's happening. It will produce oxygen gas. Okay, when it produces oxygen gas, we will always relight a glowing spleen. Okay, O levels and IP students, this is your very important in the practical. They will always test you on this. Okay, the sulfide ions or the sulfur dioxide gases, these are reducing agent again. They will be oxidized to give you sulfate ions. So you can see there's an increase in oxygen. Okay, this part not so much. They will not really give us in the practical as well. Okay, sodium thiosulfate, this is mostly for your IP students. Okay, sodium thiosulfate, it will remain colorless, but it will cause your oxidizing agent to change color. So if I have sodium thiosulfate plus, example, KMnO4, okay, your KMnO4 will turn from purple to colorless. Okay, and when you know it turns from purple to colorless, you have to know that this is your reducing agent because KMnO4 is your oxidizing agent. Okay, carbon monoxide, again, these are reducing agents because it will be oxidized to CO2. Okay, and then iron 2, Fe2 plus will tend to form Fe3 plus and gain electron. Okay, so when it gains electron on the product side, this part they will lose the electron. So oxidation is lose, it is being oxidized, is the reducing agent. Okay, 2 plus is green and it will turn into red brown.